Hello everybody, this is for lesson 6.2. In this video I'm going to talk about what the natural base E is and different things that you can do with that. The first question is, what is the natural base E? Here's the information on it, and I wrote this down in class at the end of class yesterday. The idea here is if you take 1 plus 1 divided by a really big number, and then you raise that number, whatever you get in parentheses, to another big number, and you let that big number get as big and big and big as you want, you end up getting the number E. E is just like pi in the sense that pi goes on forever, so it's about 3.14, but then it goes on forever. It's approximately equal to 3.14. It's equal to, I'm trying to be technical here, even though I don't really need to be at the moment. E, again, is a number that is about 2.71 or 2.718. But the number goes on forever and ever and ever. Okay? The definition, by the way, the definition of E, you don't actually need to know. Like, I'm not expecting you to remember 1 plus 1 over a big number raised to a big number, which I just showed you where the E is coming from. You do need to know, you do need to know that E is 2.718. Okay, now continuous compound interest. So we're going to start off with the problem here. So last time we were in class, we looked at compounding annually and then monthly and then daily. And then we even went hourly and minute, and we even compounded to the second. And if you were in class to do that activity, you saw that the amount did not change as you started going to seconds. The number changed in the far decimal, but the dollar, the dimes and the cents did not change. The pennies did not change. And the reason this is because we used E without knowing it. And I'll be short here. A is equal to PE to the RT. A is equal to PERT. And this is going to be a new formula. And this allows us to compound all the time. So we use the word compound continuously. And whenever we compound continuously, we're using this formula. And what that means is we're taking our interest and dividing it up like beyond every second, continuously, without any interruption. And it's going to be easier in the sense that we don't have that long, complicated formula. We're just going to have P times E to the RT. I want you to also know that we are doing a times between P and E, and RT should be multiplied together. I also had before that P is the starting amount, and we did a little bit of this the last time. P is the starting amount. P is starting amount. R is the rate as a decimal. Not sure how to do that still. Remember, just take that rate and divide it by 100. And T is always in years. We're going to go to the next page and try a problem. You have an option to deposit $4,250 in an account that earns 5% annual interest compounded continuously, or $4,000 in an account that earns 7% annual interest compounded monthly. Which account should you choose to make the most? So what I'm going to do first is I'm going to start with my first information here, which is $4,250 with compounded continuously. So compounded continuously, again, means A is equal to P times E to the RT. I'm writing a little bit slower because people tell me that my handwriting isn't so great in the videos, so hopefully this is better. P here is going to be 4,250 because that's your starting value, that's your deposit. Your rate is going to be the 5%, but 5% as a decimal is 0.05. If you weren't sure how I got that, please take 5 divided by 100. And you get 0.05. And then time, it looks like we're going to just do time, assume time is just 1 year. Usually we'll tell you longer, but T is going to be equal to 1 year. Let's go and plug in our numbers here. In blue, we get A is equal to 4,250 times E to the 0.05 times 1. And then for the other one, and you'll just get a number here, and I'll do that in a second. For the other one, please pause the video and try to do that one on your own. 4,000 and then 1 plus 0.7 divided by, is it? Oh boy. All right, so let's do divided by 12 to the 12. Okay, let's see which one gets us more. With this. Times, now e to the x, that's going to be second ln, and I think it was 0.05. Well, you can do times 1. Okay, that's $4,467.90. Here. Let's see what the other one gets us. We'll put a red box around the answer. So here we're going to get 4,000 times 1 plus 0.07 divided by 12. Raise that to the 12th power. And that's going to be $89. So this is $4,289. And obviously, account 1 wins. So with more interest, we still win, but we put less money in. At $4,289.16. Okay. There's your answer for that. In red is the actual answer. Which account should you choose to make the most money? This one. Next. Okay. So now we can do any function to an x power. We can do e to an x if we like. So the left side is e to the x, and that's called exponential growth. The right is e to the negative x, and that's exponential decay. And let's just look at each of these and see if we can graph each one. To graph this one, 3e to the x. First, before we even try to graph it, this is growth. Because, again, when we have a number, and we got to be careful here, when we have a number to a negative exponent, that's usually going to be decay. And when we have a number to a positive exponent, that's usually going to be growth. But I'm going to give you a chart in class that's going to help you unpack that a little bit more, because that's not always true. For this one, e to the negative 0.5x, that's going to be decay because of the negative sign in here. And then that's it. You can go ahead and just graph these on your own in the table, and you'll have the graph of the function just plot on there. And I believe that's it. Thanks for watching, guys.